All right, let's get started. So thanks everybody for joining our webinar today on printing in-mold electronic prototypes for automotive applications. I'm your host today, Nathan. I'm the support lead here at Voltera. So before we jump into the webinar, I thought we'd just kind of go through a little bit of the agenda for today and cover, just some logistics as well. So the webinar today will be about 1 hour long, so feel free to post your questions in the chat box throughout the presentation today, and I've got a couple of colleagues there with Dash Volterra as their name ready to respond. And we also have some folks from some partners who I'll introduce throughout the presentation today, and they're here as well to answer about their products. And we also want to remind you just to stay until the end of the presentation today. We're going to be giving a promo code for $2,000 off a Nova. So for the agenda, here's what we'll cover today. First, we're going to start with just a bit of an industry and project overview for in-mold electronics. Then we'll go into some tips and tricks for printing IMEs. We'll cover the post-processing, what happens after a print, and then we'll finish off with a live demonstration where we'll be doing a live print on Nova for you. There should be plenty of time for questions at the end of the presentation as well. So feel free to ask anytime throughout as well. Let's jump into an overview of the in-mold electronics industry, and specifically the in-mold ink we decided to use and details about our project. So what are in-mold electronics, or IMEs? IMEs are the process of incorporating electronic elements into molded plastic objects. They typically consist of the following processes. So producing a thermoformable circuit, in our case by printing. A lot of times there are other methods that are used as well, such as screen printing. Then the next step is thermoforming the circuit onto a designated 3D shape or a buck. And then you finish off the project by injecting a thermoplastic polymer to encapsulate the electronic device and just add some strength and rigidity to the finished part. The final part is a functional rigid plastic component that's typically fairly lightweight, and it's got the electronics fully integrated into it. And a little bit of market trends from research that we've looked up. So according to the market report by Verified Market Research, the IME market is projected to reach about 277 million USD by 2031. So we're going to see substantial growth in this industry, in this market, over the next few years. So some typical applications for in-mold electronics. They're mainly used in the automotive industry, and they do have applications in some consumer electronics as well. But in the automotive sector, IMEs are used to create kind of advanced interfaces such as touch-sensitive dashboards, integrated lighting, and control panels. And this technology replaces traditional mechanical buttons, wires, and connectors, which are prone to wear and tear and failure. And this enables a cleaner, button-free interface that integrates seamlessly with the vehicle's interior. So, as I mentioned earlier, the circuit undergoes thermoforming as part of the in-mold electronics process. And this means that the material used must withstand the demands of thermoforming and injection molding. These are typically high temperatures, pressure, and elongation. So when choosing a conductive ink for an IME project, it needs to provide high electrical conductivity. That's the fairly straightforward part. But yeah, it just needs to have really strong adhesion and be able to hold up to those demands. So for our project today, we selected Bectron CP6680. It's a thermoformable conductive silver ink by Elantas. This ink specifically is optimized for in-mold electronics. So this ensures that we're going to have the durability and performance we need in the tough conditions. So it was a perfect choice for us today. And we also have Philip Holtzel and Ben Elhart here today from Elantas. Philip and Ben are both technical sales managers, and they're available to answer any questions you have regarding their IME ink in the chat as well. So feel free to ask those there. Great to have you, Philip and Ben. So a bit of a project overview here for you all. These are kind of the quick steps to go through the project we're doing today. It's definitely not a how-to guide, but more of just an overview. And I guess I'll start by just kind of showing off what the final product looks like on camera here as well for you. So this is our final product here. So we have a kind of 3D shape with the printed electronics directly involved, and we've already populated these with some connectors and some LEDs around the board. And as you can see, this thermoformable plastic was formed around a 3D object. This is what that object looked like. So we used a vacuum former to mold the object around the shape. So that's kind of our end result for our project here. And yeah, we've basically got kind of two touch button interfaces. That was the idea of this project. So kind of the steps that we took to get there. Before we start printing, we need to design a circuit and export it so that we can use it in the Nova software. So in this case, we designed a Gerber file, which is the industry standard for circuit design. And then after that, we needed to get our ink ready for printing. So this might involve down packing the ink from a larger container into a 5cc Nordson cartridge that we use for Nova. And sometimes this requires mixing the material to remove all the air bubbles. So we use a dual planetary mixer here at Voltera to do that. Once we have kind of our file ready and our ink ready to go, we need to jump over to Nova and dial in the settings for our ink. So we use the calibration process on the calibration procedure on Nova to do that. And this is an iterative print process that is fully guided by the software, and it helps you dial in the print settings for your material, where you only need to make kind of one or two small tweaks at a time until you get the settings that you're looking for. It's worth noting that this only needs to be done the first time you print with a new ink and nozzle combination. And once it's calibrated, it's saved into the software, and you can come back and use those settings anytime for future prints. So once we have our ink fully calibrated and ready to print, we can move on to printing. So that's our third step. And that's what we'll be demonstrating here live shortly. So I'll go into it a little bit more detail then. Once our print is done, we proceed to curing the circuit. And for our Bectron CP6680, we put it in our lab oven for 10 minutes at about 120 degrees Celsius. And for the post-processing, so after we finish curing, that's when we move into actually turning our shape into a 3D object. So for this post-processing, we need to thermoform our print, populate the components, and secure the connectors. So the thermoforming is a step where our project really starts to take its shape. There are a couple of steps to thermoforming the print. First, we need to design the vacuum forming buck, which is what I showed on camera a little bit earlier. So in our case, this is 3D printed. So we 3D printed our buck, ensuring that it kind of gave the 3D look we wanted our final object to look like. And then once that 3D printed buck is set up, then we can vacuum form our print onto the plastic over top of that buck. Perfect. And just to kind of give a definition of the buck, a buck is a solid mold or form used to shape material during the vacuum forming process. It serves as a bit of a template for the heated plastic sheet to be draped over and pressed against. For this, we utilize a Make-U Formbox vacuum former to shape the print. So this is what the MakeU form box looks like. And we also have Benjamin Redford, founder and CPO at MakeU with us today. So Benjamin's also available to answer any questions you have regarding the MakeU form box in our chat. We've been using the form box for quite a few years now, but MakeU also has a new product called the Multiplier, which is a pressure former. So it's got a bit more versatility, and it's a great option for in-mold products like or projects like the one we're showing off today. So yeah, feel free to ask Benjamin any questions you have as well there in the chat. So just a couple of quick best practices now that we've kind of gone over what the project looks like. So when you're designing in-mold electronics that will undergo this thermoforming process, it's crucial to consider a couple of factors to make sure that you're going to have the durability that you need and the functionality that you're looking for. So first, you want to ensure that areas where the components will be attached experience as minimal stress and remain as flat as possible. And this is just so we can prevent any detachment in the future. Next, you want to avoid designing with excessively sharp corners or extreme features, as the thermoformable inks have a limited to their stretch capacity, as well as the substrate itself. It can only be stretched so much, so it's important that you're keeping that in mind so we're not going through any extreme bending. Finally, you want to consider just the ergonomics of your design. You want to aim to have it be intuitive in function, and that it's going to be easy for a human to work with that. So you might want to think about, okay, am I incorporating a horizontal slider for controlling a fan speed or having graphics to reflect it? Keeping all those things in mind is key. Perfect. So yeah, now we're just going to jump into the live demonstration. And just a quick reminder that we have our folks from MakeU and Elantas in the chat. If you have any questions about the ink we're using today or the thermoformer we used for our project. And we also have a couple of Voltera representatives in there as well to answer your questions as we continue through this demonstration. Perfect. So I'm just going to switch my screen over. There we go. Perfect. So now we're in the Nova software, and I'll just give you kind of a quick lay of the land here, just so you get some familiarity with it. But this is the home screen for Nova software. You can see right in the direct center, we have a couple of workflow tiles. So we've got dispense, materials, and calibrate. Today, we're going to be focusing just on the dispense workflow. But then, throughout the software, we've got some buttons at the top that'll be available to us. These are things for homing the machine, stopping the machine, reviewing our print settings. And then we've got a variety of machine settings in the bottom left corner and just information for us in the bottom right as well. So for today, we already, like I mentioned, we already have our ink calibrated and our substrate ready to go. So we're just going to jump right into the dispense workflow. Perfect. So once you jump into a dispense workflow, you'll see the software changes a little bit. All of our user inputs are going to show up here on the left-hand side, and then we'll get a bit of a visual representation of the work area here in the center. So you can see the outline here is representing our vacuum module. And then there's a big gap here left on the right-hand side for helpful tips and tricks as we're going through the software. So we'll see a couple of those as we go through here. But to start, I'm just going to grab a file from my computer. And I have my in-mold electronics webinar Gerber file here ready to go. So I'm just going to load that up. And we can see that Nova was processing the file there, and then it has been loaded in. So it's recognized the shapes that we're looking to work with. So now I'm able to click Next to move forward in the software. So now I'm prompted to choose the materials that I'd like to work with. So like I mentioned earlier, I already have this ink dialed in and ready to go. So I just need to find it in my list of inks. So there it is, the Bectron CP6680. And I'm just going to choose the batch. So I'm using a Nordson 150 micron nozzle with that today. And then I just need to select my substrate. So here's my polycarbonate substrate. And now I can generate the tool paths. And we can see that Nova is now working to generate those tool paths, and we'll see them load in as they happen here today. And so these tool paths are being generated based on our print settings. And so I can take a look at our print settings here anytime for our ink, as well as our substrate, just clicking the settings cog in the top center menu. And that's what's being used to generate those tool paths for us today. So I will click next now that they're all loaded in. And I'm being prompted to mount my substrate, which I've already done here on Nova. But you can see in the top right, this is a great example of kind of the helpful tips and tricks that you can look through as they pop up. So this one's just showing us how to get the vacuum module in place and how to put our film on top of the vacuum module. And I'm also notified that the vacuum is going to turn on when I move to the next step here. So you guys probably won't hear it too well on camera. My microphone's pretty good at noise canceling, but if you do hear it, that's what's turning on in the next step here. Perfect. So this step following the substrate setup is the alignment step. This step can be really helpful if you need to specify where on your substrate you want to print your circuit. Sometimes you want that to be very precise and exact, and other times you just want to print it anywhere on the substrate. So this step helps you do that. For today, I'm pretty happy just printing right in the middle of the bed. So I'm just going to skip right through this. But we've got a lot of great helpful docs and resources available that if you're looking for more information on this, you can check out at docs.voltera.io. So yeah, lots of great support resources there for you. And yeah, alignment's one of those that you could get a bit more info on. Perfect. So now that we've got our circuit printing where we would like it to go, right in the center of our work area, we now need to measure the height of our substrate. So we're going to use Nova's Smart Probe to do that. And it's going to generate a height map for us to then print on. Because even though our substrate seems super flat and uh, super even. Once you get to these finer multiple micron levels, yeah, there actually is a bit of topography there. So it's really important for us to get a good idea of what our height map looks like in order to print on it. So all of our tools are just measuring on the XYZ positioner switch at the front of Nova here right now. And once they have done all that measurement, then we will move to probing. And we can see that the probe tip is measuring first on the top of the XYZ positioner to get its Z position, so its height position. And then you can see it measures on either side of the thumb screw, both front and back and left and right, to get those X and Y positions so that we have a really good idea exactly where the tip of that probe is, so that when it then goes to measure our substrate, we get a great three-dimensional height map of our substrate for our dispenser to follow along. And you can see in our software that as we start probing, our progress bar starts to complete, and we can see how far along we are. And additionally, you can see that once we probe points in our substrate, they start to fill in with a solid blue circle as well. So we get some nice visual feedback here of where we are in the process. And you might be wondering how the software decides where it needs to probe. So this is all automatically done by the software. It calculates where the probe points need to be, and that's based off of the probe pitch setting in our substrate settings. And so that setting controls the maximum distance two probe points should be away from each other. So you can control how dense or how undense the height map should be based on how accurate you want to be. Obviously, accuracy is great. The more the merrier, but the more probing points you have, the longer it takes. So yeah, our default distance is 5 millimeters apart, and we seem to think that that works well for most of our regular prints. But for things where you need a bit more accuracy, that distance can be reduced and we can generate more probing points. All right, so we are all finished measuring the height of our substrate here, so we can click next. And we are prompted to prepare our dispenser. And again, we've got some great GIFs here that are walking us through what this process looks like. And this is a great shout out again for docs.voltera.io. We've got more detailed instructions there for you if you're ever assembling one for the first couple of times. It's a great doc to have handy just for reference. But I've already done it. My dispenser's already attached to the machine, so I'll just click next. And as I click next, our dispenser is going to start heating up here. And so we're heating up the dispenser to 35 degrees Celsius. This is, again, another parameter that's controllable at a per material level. So if you have some materials that are a little bit temperature sensitive, this could be lowered or completely turned off altogether. It is important to note there's no cooling feature, so your room temperature is kind of the lowest that it can be held at. But if you don't want to apply any heating, that's possible. But we apply heating just so that we're at a temperature that's higher than our typical room temperature. So we don't have to worry about temperature as a variable with our print settings from day to day. We can just know that they're going to work the next day. And this just takes about a couple minutes to get there. And we're just about there. So what we're going to do in this step, why we're heating up for this, is we're going to do a quick flow check. Now, this isn't a full calibration of our material. All we're looking to do here is make sure that the material we want to print with today is all the way at our nozzle tip. So we're just going to print a couple of lines, and we can do this step over and over again until we have that material flowing out the way we like. But again, this isn't to calibrate the settings for our material, so I'm not going to be making likely any adjustments here. I just want to see that the material is coming out the tip of the nozzle, and that means I don't have any gapping when I do start my print. So I'm just going to click check here, and we're going to see Nova then go to measure the dispenser on the XYZ positioner. So again, this starts with the height, and then it'll move to the X and Y positions. Perfect. And once we see it finished with that, it's going to then move over to our calibration plate area, and it's going to print the 3 lines as we can see here represented in our software. And I don't need to look too closely with my eyes because the onboard camera on Nova will go and take a picture of our 3 lines once it's done, and I can inspect on screen instead. There, it's taking the picture. I'm not seeing any lines showing up currently, so we'll do another check. Like I mentioned, this step can be repeated multiple times until you see those lines appear. If this is the first print of the day, this can take a couple of tries to get there, just because we need that material to move from up in our cartridge down to the nozzle tip. So we have the start of a line here. It can be a little bit hard to see over zoom, but I can see about half a line there. So I'll do one more just so we can see the 3 lines show up for us, or more of 3 lines. Perfect. So we can see all 3 lines there showing up for us. So yeah, I'm happy with that. The material is there, so I'm ready to move to the next step. And yeah, the next step is just printing our pattern. So we can see by default the pattern's showing up fully green here. That means that the full pattern is selected. This is the default. But we can do selective prints as well, where if we only wanted to print a small section, we could start with that and then move on. So we've got all the typical kind of multi-select tool sets available to us, like most design softwares using Shift and Control. You can select multiple objects and print them individually. But for today, I'm just going to click and drag the whole thing and we'll get it started here. Now, I may not let the whole print run just because of to give us a little bit of time constraint. But yeah, I'm just going to start it here and we'll see how much we can get done before we have to move on. And it never gets old watching it print. It can be mesmerizing at time, but yeah, it's just really awesome just seeing those traces be brought to life. And if we switch over to the software, I'm just going to zoom in using the scroll wheel on my mouse here. But we can see traces or features as they've been printed. They become deselected, so we can see them turn blue here. So these are the ones we've already printed. Yeah, and this is just nice to get a progress report on how far along we are, besides our progress bar here on the left. And another great feature about this is if we have to pause our print for some reason, just to yeah, readjust or anything like that, we can pick up where we left off. So we don't have to reprint over the sections we've already printed, which is nice. So that selection comes in handy there. This feature right now is just a really great example of a Nova Smart dispenser. We can see we haven't had to pick up or leave the trace. We're able to print these long continuous traces without having to repressurize or anything. And that's because of how Nova Smart dispenser was designed. There's a pressure sensor that acts as intermediate between the nozzle tip and our ink. And we're able to continuously measure that pressure and hold it and keep applying or relieving as we go in order that to print these long continuous traces, which just leads to really great print quality and great print examples. We've got a question in the chat. I can see here just how big are the squares in the design? I haven't measured them actually just off the top of my head, but visually just looking at them, they're about 2 centimeter by 2 centimeters. So I think they were, yeah, referring to these kind of large square pads here. And with this design, it looks like the way the tool paths have been planned, we're basically going to be printing all the perimeters of most of these features and then fill in the squares. So that might be a good break point for us today on this print, just to pause it. That way we don't have to sit here and wait for them all to get filled in, and we'll get a pretty good idea of what our design looks like. So yeah, we'll work on printing the rest of these kind of green traces and go from there. And it looks like we've got another question in the chat. Can we adjust the print speed manually? Yes, so this is something that you can control as well on a per material level. Yeah, so again, this is just in our settings, which we can open up here, and you can see our print speed here expressed in millimeters per minute. So yeah, and if you click the question mark beside it, it also explains what the setting is all about. So yeah, 400 millimeters per minute is a little bit slower than our standard. Our standard's kind of between 500 and 600 for most materials. But we've found that the nozzle we're using today, the Nordson EFD nozzles, with their straight barrel geometry, they typically like to print a little bit slower. Just to get a full flow. So yeah, that's why we've kind of adjusted that setting there. And this is coming along really nicely. We're just about finished up all the traces. And yeah, and then once we're finished up the outer traces, we'll pause the print, and that way we'll have time to inspect it with the camera, the onboard camera, and take a look at the beautiful traces we printed, and then we can finish up from there. Okay, I think we're just about there. I think we're starting to fill in. So I'll just zoom in here. Yeah, it looks like all of our outer traces have turned blue. So I'm just going to hit pause, and the printer will work on stopping. It's just going to finish the current feature it's on, and then it'll pause for us. Hopefully I caught it in time before it does most of this pad, but we'll zoom in on it just so you can see it filling in. And again, it's able to maintain this good consistent pressure throughout printing. So great for these larger fills as well as those longer thin traces. We just get nice consistent print results here. While this is finishing up, I think we've got another question just about what do the print settings adjust? So there's quite a few print settings. Um, and like I mentioned earlier on, each of them has a little question mark beside it that you can click to bring up the help section for them. And it's got a little bit of an explanation there. But it's a good time to highlight our support docs as well. So docs.voltera.io. We've got a page that goes through each of these print settings there as well and explains in a bit more detail. So that's a great resource for you. And we also have our support team, support@voltera.io. We'd be happy to explain as well. So feel free to reach out to us and we can help you with those print settings as well. All right, it's just about finished up here. So nice little fill there. Great. And we're moving the dispenser back into the homed position there. And awesome. And it's, yeah, just homing the dispenser. So pulling back on the pressure. And now let's move to the next step here. So I'm just going to click next and we can inspect our print. So you can see our camera feed immediately opened up in the bottom left here. And that's just showing us the current position. So that back right corner. Obviously, we want to move to our print to inspect it. And we've got a couple of ways we can go about that. So we've got these arrow keys here that we can control just by clicking or using the arrow keys on our keyboard. And the current step size is 50 millimeters, so about 5 centimeters at a time. And we can just click on the center number there to adjust that step size. So from 50 down to 10, down to 1. And we can also just click anywhere in our kind of map view here to send the camera there. So I'm going to swap the camera so it's center. And then I'm just going to click on kind of the center of our design, kind of where all those pins and pads are. And we can take a look at our traces here. So we can, we've got a couple of options here. We can autofocus and the camera will refocus on that specific area. Great, now we're in focus. And we can also zoom in if we like. So we can click that to get a little bit of a closer detail. And sometimes it can be a little tricky, like printing a silver ink onto a silver colored background to see the detail and the contrast. So we can actually toggle through some of the light controls here. Green looks pretty good to see our print results. And sometimes just having the lights off altogether gives us a good view here as well. So I'm going to keep those off. I'm just going to adjust step size here and use the arrow keys to toggle the camera here. Okay, yeah, so we've got some pretty good print results. I'm just going to look at this pad. Oh yeah, that pad looks beautifully filled. And again, I can click on the map in the bottom corner too to force the camera to go there. And yeah, we can basically kind of follow our entire print all the way around and just inspect the print results. But yeah, this looks really great today. So I'm pretty happy with these results. So I can just click next and give it a thumbs up. And yeah, you can see I'm prompted to save the job if I want. So if this is a print that I want to do regularly, I can save this design, the materials we used, as well as the alignment on our substrate, and bring this up for another print session. So just save a little bit of time. But today I'm just going to click finish here. Our vacuum's going to turn off. And yeah, I think that's going to be just about it for our webinar today. I'm just going to switch over back to our slides here. So we will leave the webinar running for a few more minutes in case there are any last minute questions in the chat. But if you do have any questions after the webinar today, please reach out to sales@voltera.io and we'll get back to you as soon as possible. Additionally, if you have any questions about the in-mold ink we used for this project, the Bectron CP6680, please contact Elantas at advancedprinting@altana.com. So that's advancedprinting@altana.com. And if you have any questions about the thermoformer we used for today's project, the Formbox, or Makeu's new product, the multiplier, please reach out to support@makeu.me. Awesome. And as promised, we do have the promo code for you today as a thank you for attending today's webinar. So use the promo code INMOLDINK, all one word, all caps, to get $2,000 off the purchase of a Nova. And yeah, that includes for the webinar for today. So again, I'll leave the chat open for a few minutes if there's any additional questions. But yeah, thank you for your time and we'll see you later.